Hello my dear students, welcome to my physics class. Our today's topics: Ohm's law, resistance, law of resistance, types of resistance, and color code of resistance. Ohm's law. This is a current versus potential difference graph. In this graph, we can see in the x-axis potential difference is given, and in y-axis current in milliampere is given, and in the positive x-axis positive potential difference, and in the negative x-axis here negative potential, that is 1, 2, 3, and -1, -2, -3. Similarly, in the positive y direction, the positive current 1 milliampere, 2 milliampere, and 3 milliampere, and in the negative y direction -1 milliampere, -2, and -3. Here, for the first conductor, if we apply a potential difference, then we will get a current. Here current is given in milliampere. When the potential difference is increased, then current in the conductor through the conductor is increased. Here the given graph, here potential difference is increased, current is also increased. If we reverse the electric cell, or if we reverse the potential difference, that is if the potential difference is increased in negative direction, that is -1 volt, -2 volt, -3 volt, then the current is reversed, that is negative current will be obtained if we reverse the potential difference. That is, potential difference is increased, current is increased. Potential difference in the negative direction is increased, in the negative direction current is increased. That is, if we reverse the potential difference, then the direction of the current will be changed. In the second conductor, here potential difference is increased and current is also increased. If we reverse the potential difference, here current also will change the direction. There is a difference between two graphs for conductor A and for conductor B. Here the for same potential, current in case of first conductor is more than the current in the second conductor. For the same potential difference in first conductor, current is more than the second conductor, because the resistance of the first conductor is less than the resistance of the second conductor. In case of second conductor, the resistance is more. Therefore, for the same potential difference, the current in the second conductor is less than the current through the first conductor. From this graph, we can see that with increasing potential difference, current will be increased. With decreasing potential difference, current flow through the conductor will be decreased. This is the Ohm's law. At a fixed temperature, the current flowing through a particular conductor is directly proportional to the potential difference between two ends of the conductor. Here a conductor is given, AB is a conductor. The potential at point A and B are V and V, that is, at point A potential is VA and point B potential is VB. If VA is greater than VB, that is, potential at point VA is greater than potential at point B, that is VB. Therefore, we can write potential difference V is equal to VA minus VB. If the current flowing through the conductor, that is I current is flowing through this conductor from A to B, because here potential at point A VA is greater than the potential at point B VB. Therefore current is flowing from higher potential to lower potential. Now according to Ohm's law, current flowing through this conductor I is proportional to the potential difference between two ends A and B. That is, current flowing through a particular conductor is directly proportional to the potential difference between two ends of the conductor. Here potential difference between two ends of the conductor is V and current flowing through this conductor is I. Therefore you can write I is proportional to V. I is proportional to V, or I is equal to GV. Here G is a proportional constant and it is known as conductance of the conductor. Here G is the proportional constant, that is I is equal to GV. This is the conductance of the conductor. Its unit is reverse of ohm, that is mho. OSM ohm, its reverse is mho, or Siemens, it's denoted by S, or per ohm. And we can write G is equal to 1 divided by R, here as the resistance of the conductor, that is conductance is the reciprocal of resistance. If the resistance of a conductor is more, then the conductance of the conductor will be less. Therefore we can write here I is equal to GV and G is equal to 1 divided by R. Therefore we can write I is equal to V divided by R, or V is equal to IR, or R is equal to V divided by I. Here V I into R. Here I is equal to V divided by R is equal to V divided by I, and V is equal to IR. From this figure easily we can determine the relation between IV and R. Resistance. When current flows through a conductor, electrons collide with atoms, molecules, or other electrons. Therefore their motion is obstructed and current flow is resisted. This property of the conductor is called resistance. The unit of resistance is ohm. That is, resistance is a property of the conductor. More the resistance, less the conductance. Resistance of a conductor depends on temperature, material of the conductor, length of the conductor, and cross-sectional area of the conductor. The resistance of the conductor depends on temperature, material of the conductor, length of the conductor, and cross-sectional area of the conductor. If the temperature is increased, then the resistance of a conductor will be increased. And if the material of the conductor is changed, then the resistance of the conductor will be changed. And resistance of the conductor depends on length of the conductor and cross-sectional area of the conductor. Law of resistance. Law of length. If the temperature and cross-sectional area are constant, the resistance of a conductor of fixed material is proportional to its length. If the length of a conductor is L, cross-sectional area is A, and resistance is R, then R is proportional to L when A is constant. If the material, temperature, and area, cross-sectional area of the conductor is constant, then R is proportional to L. That is, if the length of the conductor is increased, then the resistance of the conductor will be increased. More the length, more will be resistance. Law of area. If the temperature and length are constant, the resistance of a conductor of fixed material is inversely proportional to its cross-sectional area. If the length of a conductor is L, cross-sectional area is A, and resistance is R, R is proportional to 1 by A. That is, R is inversely proportional to the cross-sectional area when L is constant. That is, if temperature, material and length of the conductor is constant, then R is inversely proportional to the cross-sectional area. If A is increased, then R will be decreased. If A is decreased, R will be increased. More the cross-sectional area, less will be resistance. Less the cross-sectional area, more will be resistance. That is, the if two conductors of same length, same material, if one conductor has more cross-sectional area than on another, then the resistance of the conductor whose cross-sectional area is more will be less resistance. From laws of resistance we get, from the law of length we get R is proportional to L when A is constant, and R is inversely proportional to cross-sectional area when length is constant. Therefore, combining these two laws, we get R is proportional to L divided by A when L and A are variable. Here L and A both will be changed. R is proportional to L divided by A, or R is equal to rho L by A. Here rho is a proportional constant, and R is equal to rho L divided by A. Here rho is a proportional constant. It is known as specific resistance or resistivity of the conductor. This rho depends on the material of the conductor. It is known as resistivity or specific resistance. It is the property of the material. We can get concept about the material of the conductor by the value of resistivity or rho. Rho also depends on temperature. We know if the temperature of conductor is increased, then its resistance will be increased. Therefore, if the temperature of a fixed material is increased, its resistance will be increased. Specific resistance or resistivity, here R is equal to rho L divided by A, or rho is equal to RA divided by A. By simplification, rho is equal to RA divided by L. When A is equal to 1 meter square and L is equal to 1 meter, from the above equation we can write, from this equation we can write rho is equal to R, because here A is equal to 1, L is equal to 1 divided, that is rho is equal to R into 1 divided by 1 is equal to R. At a fixed temperature, the resistance of a conductor of unit length and unit cross-sectional area is called the specific resistance or resistivity of the material of the conductor. That is, if we consider a conductor whose cross-sectional area is 1 meter square and length is 1 meter, then the resistance of that conductor is the resistivity or specific resistance of the material of that conductor. Its unit is ohm meter. From the resistivity of the conductor, we can know the material of the conductor. So resistivity depends on material and temperature only. Specific resistance or resistivity, here the specific resistance or resistivity of some metal are given. Here for silver 1.59 into 10 to the power minus 8 ohm meter, for copper 1.68 into 10 to the minus 8 ohm meter, for gold 2.44 into 10 to the minus 8 ohm meter, for graphite 2.50 into 10 to the power minus 6 ohm meter, for diamond 1 into 10 to the power 12 ohm meter, and for here 1.30 into 10 to the power 16 ohm meter. From this table we can see the specific resistance or resistivity for silver is lowest. As a conductor, silver is better than copper. That is, less will be specific resistance, more will be conductance. In case of silver, specific resistance is lower than the specific resistance of copper, therefore it is as a conductor better than copper. In case of copper and gold, here specific resistance 1.68 into 10 to the minus 8 ohm meter, and for gold 2.44 into 10 to the minus 8 meter. In this case, the copper is better than gold. And here also the diamond, graphite is also a conductor. Here its specific resistance is 2.50 into 10 to the minus 6. Graphite is a non-metal. Though it is a non-metal, it can conduct current through it because its specific resistance is very low, therefore it is a good conductor. And diamond is not a conductor, its specific resistance is very high, 1 into 10 by 12. Though graphite is also carbon and diamond is also carbon, but the two forms of carbon is graphite and diamond. Graphite is conductor but diamond is non-conductor. For air, its specific resistance is very high, 1.3 into 10 to the 16. It's non-conductor. Specific conductance. How a material is conducting, we can know this by the specific conductance. The reciprocal quantity of specific resistance is specific conductance. It is denoted by sigma. The concept of resistance can be got by the specific resistance, and the concept of conductance can be get by the specific conductance. Here specific resistance depends on temperature and material only. Specific conductance is also depends on material and temperature. Here sigma is equal to 1 divided by rho. It's the reciprocal quantity of specific resistance. Its unit is per ohm meter. The more will be specific conductance, it can pass more and more current through it. Here quantity and it is reciprocal quantity. Resistance, its reciprocal quantity is conductance, and specific resistance or its resistivity, its reciprocal quantity is conductivity. That is, reciprocal quantity of resistance is conductance and reciprocal quantity of resistivity is conductivity. Here the unit of resistance is ohm, unit of conductance is per ohm, unit of resistivity is ohm meter, and unit of conductivity is per ohm meter. Types of resistance. Fixed resistance. Resistors of definite value are used in different circuit. The resistance of fixed value is called fixed resistance. Generally, the value of resistance are expressed by using color band on them. That is, a fixed resistance, its value is fixed. This type of resistance is used in laboratory. Here we can know the resistance, the value of the resistance by the color on them. There are 4 colors on the resistors. By observing these colors, we can know the value of the resistance of that resistor. Its value cannot be changed. This type of resistance is known as fixed resistance. Here these are the fixed resistance. Here given color 1, 2, 3, 4. There are 4 colors band on each resistor, different colors. each color express a unique number. By these colors we can get the value of this resistance. Variable resistance. The resistance whose value can be changed within a certain limit is called variable resistance or rheostat. We can change the value of the resistance within a certain limit, from lower limit to higher limit. We can set the any value between lower limit to higher limit. Therefore, its value is variable, and therefore this resistance is known as variable resistance. Its value is not fixed. For our purpose, we can change the value. Here, this is a variable resistance. Here, another. It's a variable resistance. It's also variable resistance. By moving this part, we can change the resistance. We can move this. If we move this, the resistance of the resistor will be changed. Here also we can move this part. Here we have to connect one end here and another end here. Then if we move this part, the resistance will be changed, and we can change the resistance from here to here. Therefore, we can change the resistance within a certain limit. Up to this limit we can change the resistance. Here also, by rotating this part, we can change the resistance. These are the variable resistance. Color code of resistance. Now we will learn how to determine the value of resistance by observing the colors on them. There are 4 color rings or bands on a resistor. Each color expresses a unique number. There are first band, suppose this band is A, second band, this band is B, third band, consider it is C, and fourth band, consider D. Actually, from first, second and third band, from these 3 bands we can determine the value of the resistance, and with the help of fourth band we can determine the tolerance, how much resistance can be more or less, that is tolerance in percentage. We can determine this with the help of fourth band, that is from first, second and third band we can determine the actual value of this resistance, and fourth band will express the tolerance, that is plus something percent or minus something percent. Resistance of this resistor is here first band A, second band B. We have to write first band number and second band number together, A, B. A is the number of first band, B is the number of second band, into 10 to the power here third band number C. If the third band is C, then we have to write 10 to the power C. Suppose here first band is 3 and second band is 2. We have to write 3, 2 into 10 to the power. Suppose the third band number is 2, then we have to write 10 to the power 2 plus minus D percent. Fourth band is D. On the depending on the color, it will express as percent, that is if this color express 5%, here plus minus 5%. If this color express 10%, plus minus 10%, that is the value will vary plus 10% or minus 10%. Color code of resistance. Here color number for first, second and third band. For first, second and third band this will be used, and here for fourth band tolerance percentage is given, and for black it is 0, for brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9, golden. Tolerance is if the fourth color is golden, then it will be plus minus 5%, and if the fourth color is silver, its tolerance will be plus minus 10%, and if there is no color in the fourth band, then the tolerance will be plus minus 20%. If only 3 colors are given, first, second and third, and there is no color in the fourth band, then tolerance will be plus minus 20%. Here the black, brown, red, orange, yellow, green, blue, violet, gray, white. Very tough to memorize this. BB, Roy, good boy, very good worker. BB, Roy, good boy, very good worker. We can memorize this by this formula. And in Bengali, Kabala koho shoni bedhusha. Kabala koho shoni bedhusha. Ka kalo, ba badami, la লাল, কহ ক কমলা, হ হলুদ, স সবুজ, নি নীল, বে বেগুনি, ধু ধূসর, সা সাদা. কা বা লা কহ শনি বেধু সা. And in English, B Roy, good boy, very good worker. Now we will determine the resistance here. Resistance of this resistor will be here. This is a red color, and in this table the value of red is 2. Here A is equal to 2. And second color, yellow, the value of yellow is 4. And here orange, the value of orange is 3. Orange is 3. And fourth color, that is golden. The golden means plus minus 5%. Now we will determine the resistance of this resistor. AB into 10 to the power C plus minus D%. That is, A means 2, 2, B means 4, 2, 4. That is 24. 24 into 10 to the power C means 3, 10 to the power 3 ohm. That is, the resistance of this resistor is 24 into 10 to the power 3 ohm. That is 24 kilo ohm. The resistance of this resistor is 24 kilo ohm. And here fourth band is gold, therefore tolerance is plus minus 5%. That is 24 into 10 to the power 3 ohm plus minus 5%. That is, its value will be 24 into 10 to the power 3 ohm plus 5%, or 24 into 10 to the power 3 ohm minus 5%. That is, its value will be between 24 into 10 to the power 3 ohm plus 5% and 24 into 10 to the power 3 ohm minus 5%. The specific resistance row of silver, copper, tungsten and nichrome wire are 1.6 into 10 to the power minus 8 ohm meter, 1.7 into 10 to the power minus 8 ohm meter, 5.5 into 10 to the power minus ohm meter, 100 into 10 to the power minus 8 ohm meter. Here 4 specific resistance for 4 different materials are given. Using this, make a 1 ohm resistance. Here the specific resistance or resistivity of the materials are given. We have to make a resistor whose resistance will be 1 ohm. That is, we have to choose the length and cross-sectional area of the conductor. Therefore, its resistance will be 1 ohm. Here specific resistance rho are given. Solution: we know R is equal to rho L divided by A. We have to make R is equal to 1 ohm. That is, in this equation we have to put R is equal to 1, and rho are given for different materials, that is for silver, copper, tungsten and nichrome. Rho are given, and we have to choose L and A, that is by choosing length and cross sectional area A, we have to make 1 ohm resistance. L is equal to RA divided by rho, that is R is equal to 1 ohm, rho are given, and A, we have to choose A. R is equal to 1 ohm. If we consider A is equal to 1 meter square, consider the cross-sectional area of the conductor is 1 meter square. We have to make 1 ohm resistance, and rho for silver, tungsten, nichrome, copper are given. We can write L is equal to RA divided by rho, 1 into 1. Here R is equal to 1 ohm, A is equal to 1 meter square, 1 into 1 is equal to 1, and here rho, that is length of the conductor will be 1 divided by rho. For silver now, L is equal to 1 divided by rho of silver, 1.6, here 1.6 into 10 to the minus 8 ohm meter, 1.6 into 10 to the minus 8 ohm meter is equal to 6.25 into 10 to the 7 meter. It's a very long length of silver. If we want to make 1 ohm resistance and cross-sectional area of the conductor is 1 meter square, the length will be 6.25 into 10 to the 7 meter, and this length is very large length. Now for copper, here for copper 1 divided by specific resistance of copper, here 5.9 into 10 to the 7 meter, this length is also a large length. For tungsten, L is equal to 1.8 into 10 to the 7 meter, this length is also large. For nichrome, 1 into 10 to the 6 meter, this is also a large length. That is, if we consider the area, cross-sectional area 1 meter square, the length for silver will be this, for copper will be this, for tungsten will be this, and for nichrome. Only for 1 ohm resistance we have to make this length for silver, this length for copper, and this length for tungsten, and this length for nichrome. Now if we consider the radius of the conductor R is equal to 0.1 millimeter, that is, now we will make the conductor very thin conductor. If the conductor wire is thin, that is radius is 0.1 millimeter, the cross-sectional area of the conductor A is equal to pi R square. This is the formula of cross-sectional area, is equal to pi 0.1 into 10 to the minus 3, that is here 0.1 millimeter means 0.1 into 10 to the minus 3 meter. We have to convert it in SI unit, millimeter to meter, 10 to the minus 3 for making meter. 0.1 millimeter is equal to 0.1 into 10 to the minus 3 meter, and this is square is equal to 3.14 into 10 to the minus 8 meter square. Now the cross sectional area is very low. Now L is equal to RA divided by O rho, that is R 1 ohm, 1 into A divided by rho is equal to A divided by rho. Now we have to divide the cross sectional area by the specific resistance to get the actual length of the conductor. For silver, L is equal to 3.14 into 10 to the minus 8 meter square, here the cross sectional area, and rho we know 1.6 into 10 to the minus 8 ohm meter, this is equal to 1.96. Now if we keep the length only 1.96 meter of cross sectional area this, then the resistance of this conductor is 1 ohm, very small length, 1.96 meter only. And for copper, the length will be 1.84 meter, and for tungsten the length will be 57 meter only, less than 1 meter, about 0.5 meter, half of a meter. And for nichrome, only 3 centimeter. If you take the length only 3 centimeter of nichrome, then the resistance of this nichrome wire will be 1 ohm. For silver wire, length will be 1.96 meter. For copper wire, only 1.84 meter. For tungsten, 57 centimeter only, and for nichrome wire, 3 centimeter. If we consider the cross-sectional area is 3.14 into 10 power minus 8 meter square, that is radius of the conductor will be 0.1 millimeter.